All right, so second half, or well, this part will be longer than the first half, which was only a half hour. We're going to start chapter 5. Again, we're in Math 21, and we're going to do 5.1 and 5.2 today. And tomorrow we'll do 5.3, 5.4, and 5.5. Chapter 5 is on probability. So maybe we should just start off with defining probability. Probability is the long-term proportion in which a certain outcome is observed. And the way we use it is we use it as a measure of how likely a random event or phenomenon phenomenon I want to say it's num, N-U-M. We use it as a measure of how likely a random event or phenomenon is to occur. Has everyone in this room seen a deck of playing cards before? I knew there was gonna be some fucking freak that's never seen a deck of playing cards. Your parents never played card games with you of any sort? Do I need to get a hold of your parents, John?
Just kidding.
Have you really not seen them, or
No,
have
I
you?
was just joking.
If you haven't seen them, it's important to know, because there's a lot of examples in this class that use decks of cards.
No,
If you
I
haven't,
play poker with my friends sometimes. Oh, I'm sorry.
now I gotta do this. Okay. So, besides Jackass, has anyone else not seen a deck of playing cards? Because if you haven't, I need to show you what, like, there's the hearts, the kings, the hearts, the spades, the clubs, the diamonds. Okay, as long as you've all seen it. If you haven't seen it and you're doing this class from home and you didn't show up to class, Google playing cards and look at images, and they will show you the 52 cards. I'm not drawing them. So what we mean by long-term proportion is I could be drawing, let's say I'm drawing cards from a deck. And I'm tracking what the suit is. And I put the card back each time. When you put the card back, the way they phrase this in the homework is with replacement. I am replacing the card after I draw it. So that's what with replacement means when you're looking at the homework. You put the card back. That way you still have a full deck when you draw the next card. You get a club, I get a fucking diamond. I get a spade. I get 2 more diamonds. And I get, fuck it, let's do it, another heart. So on the short term, I don't know how many I did here, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I drew 12 cards. And for hearts, 6 of the cards I drew were a 12. 6 out of 12 were hearts. The diamonds was 1 out of 12. Clubs were 2 out of 12. And spades were 1 out of 12.
Sure.
What?
I just see 3 diamonds.
You're right, because I didn't fucking count them when I said it. Tested you, good job. You passed, everyone else fell. Now you can fucking count to 3. You know what's funny? You're looking at me all funny, and I looked at every single suit but diamonds. I verified my clubs, I verified my spades, I verified my hearts. Didn't bother to verify my diamonds. The only one I didn't bother to verify, or I would have caught it. Okay. This is not the probability of drawing those suits. John Luca, you play poker. What's the probability of drawing any one of those suits with 1 card?
I'm not good at it. I don't.
This isn't rocket science here. If you're not good at this basic probability, you shouldn't be fucking playing poker.
48. Like 1 out of 48. See, I don't know.
There's 52 cards in the deck.
There's 52 cards in the deck.
Oh,
There are 13 cards of each suit. So let's write some shit up here for people that don't know or say they know, but they really don't know. Like John Luca plays with a special deck where there's no aces. All right, so in a deck of cards, there are 52. There are 13 hearts, 13 diamonds, 13 spades, and 13 clubs. Spades and clubs are black. Hearts and diamonds are red. So these are called the suits. Thus, we have 4 suits. There are also 13 ranks. Each suit has 1 of each rank. There's the ace, which goes by A. There is the 2, the 3, 4, the 5, the 6, 7, the 8, the 9, the 10. That's 10 so far. J is for Jack, or John Luca. That's not even how you spell John Luca. It's how you spell jackass. Q is for Queen. And K is for King. I separate them that way because these 3 ranks have pictures on them. And these are called the face cards. every once in a while, they don't do it at casinos that I know of, but sometimes people put in 1 or 2 jokers that act as wild cards. But we won't for this purposes of this lecture. And if you think there is no money in knowing how to do this shit, you are 100% wrong. In the last year and a half, I have made, I want to say it's around 13,000. I'd have to go look. Calculating probabilities for a card game like Progressive Jackpot for, it's called Club Matrix or Matrix. I think it's Club Matrix. It's a casino in San Jose. They want to do this Progressive Jackpot with a bunch of different card games, and they need to know like how come up with some rare hands. I've made like 13,000, and that was with like 80 hours worth of work. I was making like 125 bucks an hour. Easy money. Sitting on my ass, watching TV, using Excel to do most of the calculations, because all you gotta do is know what to put into Excel. You need to know the probability of how all this stuff works. For some reason, the casino does not have a good mathematician on payroll. You would think they would. I wasn't complaining. Hi, Val, if you ever see this, that's my contact at Matrix. So, the probability of drawing any one suit. You can look at it 2 ways. Let's say we're looking for hearts. I can look at it in terms of suits. Remember, probability is proportion. The proportion is going to be the total on bottom, total number of outcomes versus the desired outcome, total of desired outcome. It works just like frequency, or relative frequency. This is just like relative frequency in the way you calculate it. If I look at it in terms of suits and I wanted hearts, there is only one suit that's a heart. There are 4 different suits. If I look at it in terms of cards, this is supposed to be recording it. I don't see that on the screen. It's just looking at me. There we go. Maybe I'll put the other picture up in a second. If we're looking at it by cards, there are 13 hearts out of 52 hearts, or 52 cards. Both of these get us 0.25. If you're watching from home, this was the first page. Pause it, write the shit down. This was the second page, or watch 5.1 in another video sequence. That's all I got for you. This thing likes to show 3 different cameras. I don't know why. It likes to show that screen as well, like the whiteboard as an option. I'm like, if I've got the overhead projector on, maybe this is the one I want. Okay. Notice the probabilities I have here, not, well, one of them is 1/4. This 6/12 is 0.5. The diamonds is 0.25. Clubs is 1/6, which is about 0.1767. 0.084. I don't know. I've never done 1/12 in my head. Maybe I should just check it real quick. Ah, 0.83. Not bad. That's pretty good for fucking not knowing what it is. Okay, so these are short-term proportions. We said probability is the long-term. We haven't done this enough. So this is the short-term outcomes. Okay? The short-term probabilities or short-term proportions rarely match the long-term proportions or probabilities. But the more trials or experiments that you do, the short-term probability or short-term proportion approaches the true probability. This is so important to probability, they have a name for it. This is called the law of large numbers. Before I go over this as another example with you, I'll do an example that I have stuff that's got really large numbers. I want to go over some some key terms with you guys. We like to use the words sample space, and we usually denote it with an S. This is the set of all outcomes. So that's sample space. An event, which we often use E, but sometimes we use F, other capital letters. I'll use E and F a lot. This is a collection of one or more outcomes. You guys ready for some more? So we have some rules for probability that always must be upheld. Rule number one, the probability of an event E occurring and we will denote this as, let's change the color for this, P of E
What does it say after denoted?
as. Follows the following rule. 0 is less than or equal to the probability of E, which is less than or equal to 1. Where if the probability of E equals 0, the event E has 0 outcomes and is thus impossible. If P of E equals 1, the event E is the same as the sample space. Which means it's guaranteed to occur. Pause for a second, give me a chance to write it down. give you a couple examples related to a deck of cards. So, an impossible event with a deck of cards is drawing a green card. Let's go with yellow card. Green card sounds like some immigration bullshit. You can't draw a yellow card when they're all red or black. Event E, where it's guaranteed. E is drawing a red or black card. That would give us a probability of 1. I forgot to take my meds today. What?
Said Frank.
Alright. I will add a little bit more. This isn't a hard and fast rule, but if the probability of event E is less than or equal to 0.05, we say that it's unusual. And I'm gonna put unusual in quotes. We're gonna use the term unusual a lot over the next 3 weeks. Unusual means it just happens less than 5% of the time. That was rule number 1. Normally I do number 2 right away, but I thought maybe I should just populate that with some information. Two, the sum of probabilities for all events. Equals 1. They often do this to show that. Where EI is in each sub-event. Or is each event. Are you bored yet, Sarah? No? You look it. You're entertained? There's no way you're entertained. I'm not doing anything entertaining. Are you listening to music on me?
Or it's a lecture. No.
It's not too boring? Okay.
It's a lecture on math. It's not much you can do about it.
That fucking hurts my feelings. I'd like to think none of our lectures have been boring so far.
They're not boring.
If you have to, lie to me. Say you're having a fucking good time. All right.
Edge of my seat.
What?
On the edge of my seat.
That's right. That's how you do it. You all heard her? I'm on the edge of my seat. Give me more, Jones, give me more. All right, if you want, I will give you more. Okay, so probability models must meet those requirements. Which kind of tells you if you do some math and your math says the probability of an event is greater than 1, like 1.67, you did something wrong. And I am going to make a prediction, a guess here. You probably did the next fraction upside down. The probability of E is calculated as the frequency of E, how many times E happened, frequency like we did in chapter 2, over the total number of trials. This is a lot like relative frequency. Another way of looking at this is I'm going to write n in parentheses E over n parentheses S. This is the number of ways E can occur over the total number of possible outcomes. It's usually your sample space. That's why we use the S. Now, I said it's kind of like the frequency or relative frequency. Let me break down the difference for you. Frequency is a measure how often something occurs. During a unit of time. Or number of trials, or during a number of trials. If I were to shorten this, it's shit that has happened. And when I'm saying something here, I mean the event. Whatever it is we're talking about. The frequency of the event. Probability, on the other hand, is the likelihood that the event will occur in the future. Or will it happen? That's kind of, if you want to boil it down into one thing. Did you enjoy watching me wiggle one out? Brendan made eye contact the whole time I was squeezing out part. Made no face during all of it until I said something, and now she can't. She's almost spitting out her fluid. Are we there yet?
Sorry.
Okay, a little bit more. We're not done with 5.1 yet. So there's a couple of things that we look at here. Holy shit, I got ink all the fuck over my arm. What is that from? Did I write that much black stuff? No. That's worrisome. Okay, so for some stuff we do something called the classical method. This is where the outcomes are equally likely. Outcomes, the individual outcomes. Events, not necessarily the same. This pretty much like covers all of your casino games. Your dice games, your card games, roulette. The chance to draw, the probability of drawing any specific card in a deck of cards is 1/52. Probability of rolling any specific number on a six-sided die is 1/6. That's the classical method. That's when you know the outcomes are equally likely. We don't always know this. If we don't know this, we do the empirical method. And the empirical method is basically you're doing experiments. And you're doing it until you're tired of doing it. I better take my meds real quick. I pulled them out. I didn't actually take them yet. You guys ever played Pass the Pigs? I'm guessing most of you have never heard of it. I hadn't either. I didn't bring them because they're in my office in Tulare. So I'm going to show you a picture of these cute little fuckers. These guys are adorable. You're like, pigs, get the fuck out of here. There's no way. Come on, computer. Did I let you go to sleep? I let the computer go to sleep. It's a goddamn tragedy. Pass the pigs. Look at these cute little fuckers. Look at the little piggies. There's two of them. You get two piggies. And they are designed in such a way that you roll them like dice, and they can land 6 different ways. Notice one side of the piggy has a dot. The other side of the piggy that we see over here does not have a dot. So let me close out and I'll show you the list of possible things. Let me zoom in page. Nope. Oh, it's plus. So the percentages, chances of these little piggies happening is this. Side no dot means the pig rolls and the side with the dot is face down or downward, and you don't see the dot. Side with the dot is the one that's on top when you roll it, so the pig lays on its side. A razorback is if it lays, you roll it and it ends up on its back with its feet in the air. A trotter is if it lands on its feet. A snouter is if it lands on its front feet and it's leaning forward and it's on its nose. It's like doing a head plant. A leaning jowler is if it's fucking leaned to the side and it's now really just on one foot and an ear. It's fucking crazy. It doesn't happen that often. Look at that probability, 0.61%. I'm gonna write these down. So, side with no dot. This is Pass the Pigs. Cute little bastards. 34.9%. Side with dot is 30.2%. Razorback is 22.4%. Trotter is 8.8%. Snouter is 3%, 2.0%. And the leaning jowler is 0.61%. Now, these were computed experimentally by throwing the pigs, toss the pigs 11,954 times. That's a lot of pig tossing. Now, these were the probabilities, and we could see how many times they tossed them. If we want to find how many times an event occurred, multiply the total number of trials we'll call that n. It's like our sample size, how many times we threw the dice or pigs. Multiply the total trials n by the probability. This is like the n of e we said on the previous page. Lorraine taught me to pass the pigs, and I love it, and I bought a bunch of them. I got like 4 sets or some shit like that, 6 sets of them. They're not a cheap game, but I'm like, it's a teaching tool. And it's something that's like small, so I can carry it to class without like it being heavy. Of course, did I bring it right now? I should have. It's hilarious. I didn't want to go to my office. Just fuck it, you get the picture. You guys ready for more? Yep, John Lucas, all right. Let's be patient. Don't rush him.
I thought he was drawing.
He's drawing, he's fucking doing it in a very like wordy manner. You know what I'm gonna have to do one of these years? In my little introduction thing, I'm just gonna have, this is kind of long, I'm gonna have to just put in a sentence in there that says, first 10 people that email me this word get like this many extra credit points. And just see how long it fucking takes to happen. Someone did that with their syllabus, put it in the syllabus, or this is, you can look it up online. But in the syllabus, there's a locker on campus, this locker, here's the password, there's $50 sitting in there, first come, first serve. Or it's like $100, some shit like that. And at the end of the semester, he went and checked the locker, and the money's still there. Because no one read the entire fucking syllabus. Which is really kind of like a breach of contract. Syllabus is our contract with you. You should read it. All right, you guys ready for more? John Luca is done drawing. Writing, doing what the hell he's doing, trying to figure out how to play poker. Okay, so like if I wanted to see how many leaning jollers did they throw?
72, 91, or 92,
What?
72, 73.
We're gonna take the 11,954 and we're gonna multiply it by that 0.61. We're gonna turn, okay, so it was 0.61%. As a decimal, we need to move that decimal over twice. And what was it?
73, round up.
What was it before rounding?
72.99, or 92.
92. So we'll round up to 73 pigs. 73 times they threw this leaning jollar out of 11,954. Let's say we throw one more pig and it's a leaning jollar. Now how many leaning Geller pigs are there? Our leaning Geller count has gone up to 74. How many trials do we have now? We're now up to 11,955. Let's look at the probability of a leaning Geller now. It's the number of times the pig occurred over the total number of trials. Is that a big difference? No. 1/100%. This is a negligible change. Negligible change. This is kind of like an example of that law of large numbers. When they say the long-term proportion, eventually new trials have little impact on the proportion. That's the idea of the law of large numbers right there. That's played out for you. I have to know, Mateo. Why the fuck are you taking notes like that?
That's just how my brain works.
He is writing on just the right half of the fucking page. The left half of this page, like half that motherfucker is empty. Hold that shit up, show that class. I want them to see what a psychopath you are.
I have it like.
Oh, the other side you feel, so you're just like, how many notes can I pack on one fucking page? Is that everything we've done this entire semester?
This is today.
Just today, okay. I approve, I really do. When I was a student here, fucking, I was a cheap motherfucker. Engineering paper is super fucking cool. I will bring it to you guys, I will show it to you, it's great. On one side, there's graphic paper. On the other side, it's like white paper. It tends to be yellow, but the point is, you can barely see the graphing lines through the paper. So when you want a graph, you can kind of push down and draw graphs with straight lines, and graph when you want to, or it's like free space to write. Fucking paper's expensive as fuck for a student. Like when you've got a job and you make good money, well, even minimum wage, it's still pretty pricey for someone on minimum wage. So I would do shit like that with not just my notes, but my homework to turn in. I could get any fucking math class homework on one page. And finally, professor, his name was Professor Houck, he's not here anymore. He said, if you do this again, I'm gonna give it a 0. I can't read this shit. I said, okay, fuck. And I extended it to 2 pages. And he kind of rolled his eyes at me, but he's like, all right, you fucking went above 1. I'm like, minimize as little as possible. All right. So just like I did where I found, well, Sarah did the math for me over here, how many leaning dollars we got starting with the numbers, the homework is gonna ask you some shit like this. The probability of being left-handed is 0.11. If we ask 5,000 people, approximately how many will be left-handed? The way you find this is you're going to take the 5,000 and you're going to multiply it by the probability. $550 people. And that's approximately when you actually do it, it's probably unlikely to be exactly 550 people. But it should be pretty goddamn close. I'm gonna switch that blue pen out for a different blue pen. It's getting a little too light.
Isn't it a whiteboard marker?
What?
Is it a whiteboard marker?
Yeah, it's an expo marker.
There you go.
A decent. I've used regular pins before, but oftentimes they don't show up well enough on the projector. So I use these thicker things that I kind of like write big. This is way bigger than I would write on there. Like if I was writing on a piece of paper for myself, it's like 2 or 3 times larger. But it allows me to face you guys observe who's following along, who isn't, and it allows me to sit on my ass. And it allows it so I can scan these later on and provide them to students as lecture notes. So it's like a triple win. But the real reason is just so I can sit on my ass,
Valid.
right? So I've been throwing around the word trial or experiment. I've been using it, but I haven't really told you what it is. This is any process where the outcome is uncertain. Process where the outcome is uncertain. If I draw a card, I don't know what the outcome is until I draw it. It could be anything until I draw it. It's like Schrodinger's cat. Look it up if you don't know what it is. It's stupid. Some physics stupidity. And I said this earlier, an event is an outcome or collection of outcomes from a probability experiment. We'll take a break in just a second. We're almost done with 5.1. Is everyone ready for more? Oh, he's highlighting shit too. Look at this. So, like, for some examples, the probability of drawing an ace of spades. There is only one in a deck out of 52 cards. It's 1/52. The probability of drawing a heart. There are 13 hearts out of 52. So this is like any heart. This is like a collection of events or a collection of outcomes. It could have been the ace of hearts. It could have been the 2 of hearts. It could have been the 6 of hearts. Now, in Texas Hold'em, do you play Hold'em? When you say you play poker, what do you play?
Just like,
5-card draw? Okay. In Texas Hold'em, you see it on TV, like the World Series of Poker. They talk about it all the time. It shows up in the movie Casino Royale for James Bond. In Texas Hold'em, this is where the poker's at, boy. Pay attention. You get dealt 2. They're called hole cards. They are face down, and no one gets to see them but you until the end. This is also called the pocket, your pocket cards. So, this is where you get some terminology. You can start looking cool. You're like hanging out with your other fucking 16, 17-year-old friends. I know that the probability of getting a pocket pair in Hold'em is 0.0588 or 5.88%. This means your 2 cards have the same rank. Pair of 2s, 3s, 4s, etc. So this is any pocket pair. Probability being any pocket pair. The probability of a specific pair I'm going to use, this is the cool, fun terminology. They're called pocket rockets because aces look like that. And so getting ace, ace looks like you got 2 rockets in your pocket. Pocket rockets, getting a pair of aces face down. Pair like this, getting this is 0.00452 or 0.452%. This is less than 0.05% or 0.05. Sorry, this is less than 0.05, which makes this an unusual event, just to reinforce that unusual event stuff. Over today and tomorrow, you will learn how to make this calculation on your own and find those values. There is one last thing in 5.1, it's called subjective probability.
Is that a K after the arrow?
It should be a less than sign.
Oh,
Subjective probability is entirely based on personal judgment. Usually of an expert. Like a meteorologist or an economist. And with that, we'll take a little break. I'm going to stop recording here and we'll start up again in a second.